Okay, so the third type that we're going to focus on is what we call when m is greater than n. Okay, m is greater than n. And so, I don't need that big of a line. So what we're going to look at here is you're going to have maybe x squared plus x, and let's just do plus 1, okay? And you're going to have that divided by something like x minus 2. So again, your numerator, the 2, is greater than the 1. That's what we're saying here. 2 is greater than 1. And so what this one has is your oblique, okay, asymptote. Now, your vertical asymptote is just like normal. What can x not be? Your excluded values. So x cannot be 2. There are no horizontals, okay? And in order to get your oblique, we do long division, okay? So we're going to long divide x minus 2 and x squared plus x plus 1, okay? So when you go to long divide, hopefully you remember how to do it. Now, you could do synthetic, okay? That would mean you would need to put a 2 out here, 1, 1, 1, and do our synthetic division. And I can show you how it's the same thing. So what am I multiplying x by to get x squared? That's x. So x squared minus 2x. Change your signs, okay? So those cancel, and I've got 3x, and bring down your next number. So what are you going to multiply x by to get 3x? That would be a 3. So that's 3x minus 6. Again, change your signs. I don't really care about the remainder over here. What I'm looking for, again, is that linear equation. And so my oblique asymptote would be y equals x plus 3. Okay? So let's put it in, I was going to show you this here. So if I drop the 1, that's 2, 3, 6. So there's my, again, 1, 3, and then your 6 there. Whoops, I keep doing that. And so x plus 3. Okay? So definitely you could do it that way. I don't really care. It doesn't matter to me. I'm so used to doing long division because that's how I was taught, but however you want. Okay, let's get those in here. So my vertical asymptote is at 2. My oblique is at x plus 3. So I'm going to go, I should make this bigger. So I'm going to go to 3, and then I have a slope of 1. Okay, and I'm going to pull off my long division real quick. If you need to pause and copy that, I would do that. Okay, so here's my graph. Now, about the only way to do this one is to do a test point. So again, we're going to test some things. Now, I had somebody who say, well, let's try 0, okay? And so that would be an easy one on there. So we're going to put in 0. Now, hopefully you know that when I put in 0, that's going to give me 1. If I put in a 0 here, that's a negative 2. So at 0, I'm at a negative 1.5. Okay, so at 0, I'm at a negative 1/2, not 1.5. I'm right here. Okay, I like using different colors for my asymptotes and my graph. So there's where I'm at. So what that means is your graph is going to sit inside here somewhere. Okay, where? Well, that's a good question. So again, what I would do is, where was my origin at? That moved over to, sorry. Okay. not my origin, but my, what I would do is I would go in and put, again, another point. So I might choose 1 this time and just see what it is. So 1 squared plus 1 over 1 minus 2. So that would be 3 over a negative 1. So this one is a negative 3. At 1, I'm at a negative 3. 1, 2, 3. Okay? Again, you can see. If you want to check one more, I would go over to a negative 1. I'm just going to change this real quick to a negative 1. And a negative 1 here, being lazy. So that would be 1 minus 1 plus 1 over negative 3. So that's 1 negative 1/3. So at a negative 1, I'm at a negative 1/3, just a little below there. Okay, but again, that little sketch that I picked in there, so here is my graph. Okay, whoops. And again, those are my asymptotes, so it's going to come on down like this. Okay, now here's the thing, guys. If your graph is in this quadrant, it will be in this quadrant. Okay, because it can't be here and there. Okay, we don't have a square root where you would be a plus or minus, or x squared where you have 2 answers. So there's where we're at. And I could definitely check myself. Again, I'm going to get rid of this here because I could just do a quick check, and I could come in with 1, 2, 3, let's say, and check it out. So 3 squared plus 3 plus 1 over 3 minus 1. So that would be 3 squared would be 9 plus 3 plus 1. There's 13 over 1. So I am at 13. So that's going to be way up here. 1, 2, 3, 4, 5, 6, 7. Yeah, so it's it's way up here. Okay, but that's going to let me know it's going to go in like that. Okay, and again, you can plot your points and so forth. So let me have you do one on your own, and let's see how this goes. So let me give you y equals x squared minus x minus 3. And we'll do x minus 2. Let's see, how is that quite a bit different? I did x minus 2. Let's change that because I did x minus 2 last time. Let's do x minus 3. Okay. So first thing I'm going to ask you is my vertical asymptote. What is my vertical asymptote? Okay, again, remember it is your excluded values. So in this case, it's x equals 3. So if I want to, I can go ahead and get my asymptote line in. Okay. My next one is, how do I find, or what is my horizontal asymptote? The answer is there's none. Okay, so then I have my oblique. Okay, so I'm wanting that one in the form of y equals mx plus b. So how do I find my oblique asymptote? And hopefully your answer was long division or synthetic division. Okay, so if I do long division, go ahead and long divide that out, and then again, start your video and see if you got it right. So what do I multiply x by to get x squared? It would be an x. Don't forget to change your signs. That's a big one. So this is 2x minus 3. What am I going to multiply x by to get 2x? That would be a 2. So 2x minus 6. Again, on this one, I don't really care about the remainder piece of it. I'm done because there's my equation. So it is y equals x plus 2. Okay, so graph that. Okay, so it has an intercept of 2 and a slope of 1. So here is my other, whoops, I should dot that, my bad. My other asymptote line. Okay. And again, it's going to go up in there in my graph. Okay, so again, I'm going to just start checking points. I always start with, again, I would probably do 0, 1, maybe even 2. And then in this case, I'm going to go 4 and 5 maybe. And again, I might not need to check all of those, but it definitely would not be a bad idea. Okay, so I'm going to put in 0 first. So put in 0 and tell me what you get. And I get it to be 1. Because again, when I put in 0, these are all going to eliminate, and I'm out of negative 3 over 3, which is just 1. So I am at 0, 1. So it looks to me like it's probably going to be just like my last graph. Put in a 1, tell me what you get. So it looks like a negative 3/2. Okay. Again, 1 minus 1, which is 0, minus 3. And then 1 minus 3 is 2. Okay. So I'm at 1, negative 3/2. 1, 2, 3. 1, 2, 3/2. Okay. Let's try 2 real quick. Make sure we've calculated this because it's kind of looking kind of funky. Make sure we did this right. 4 minus 2 minus 3, 2 minus 3. That would be a negative 1 over a negative 1, which is 1. So at 2, I'm at 1. Double check my work because I feel like I've done something wrong on the last one. Did you guys get what I got? Let me go back and check that because that doesn't look. So I'm at 1. 1 squared minus 1 minus 3. 1 minus 3. So that would be a negative 4 over a negative. That's 2. Try that. Maybe that's better. That would be better. So I'm at 1. I'm at 2. I hope you guys caught me and said, well, she finally corrected herself. There we go. That was my bad. So, but I knew it didn't work because that did not look right. Okay. There we go. Because that wasn't. So it is going to be a curve like this. And again, the other one should do approximately the same thing. Again, I'm going to pull off this long division. So if you need it, stop and write it down. But hopefully you did that already. Okay, and let's choose what were we doing. 1, 2, 3, 4. And so 4 squared minus 4 minus 3, 4 minus 3. So that's 16 minus 4 minus 3 over 1. 16 minus 7 would be 9. So I'm at 4, 9. Whoops. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Way up here somewhere. I may have counted wrong. Again, I could find out all the things where it fit, but it's going to set inside here. So we just proved that. Okay. I know these videos got long. I apologize, but hopefully that helps you out some on graphing each of those.